Morning, folks. Brian here, Geomagnetic Earth Watch. Thursday, January 26, 2023 on our planet. I want to take you back in time during the Dalton minimum. The Dalton minimum was not necessarily a true grand solar minimum. However, it was a period of low sunspot count. Therefore, we can perhaps call it a grand minima, which was from 1790 to 1830, during which time, on April 15th, Mount Tambora in Indonesia erupted to a VEI 7 eruption. And I'll briefly go through the history. On April 5, 1815, Tambora began to awaken from its long slumber. 5 days later, on April 10, 1815, it erupted into a violent climax, ejecting ash and aerosols into the stratosphere. Now, the initial blast killed 10,000 Indonesian inhabitants on the island, on and around the island, followed by another 80,000 deaths through starvation. Now, Tambora remained in an eruptive phase for several days, and in fact, sporadic eruptions for the next 6 months to 3 years. So in comparison, it was 10 times more explosive than the Mount Pinatubo eruption. Now, the explosion again was estimated at VEI 7 with significant amounts of ash injected into the atmosphere, reflecting solar radiation, which lowered global temperatures and triggered extreme weather and crop failures throughout the northern hemisphere. This was known the following year, 1816, as the year without summer. Global, or at least the northern hemisphere, crop losses, famine. Now, please keep in mind that in 1816, the global population was estimated to be 1 billion people. Of course, it is now 8 billion people. So Mount Tambora, Indonesia, exploded April 1815, which resulted in the following year, the year without summer, severe crop losses. Now, Hong Tonga, for an example. I was watching this island, submerged island, for 12 months prior to its eruption, January 15, 2022, Hong Tonga, Haipe, and documenting the heat signatures. On December 29, 16 days before the eruption, some obvious steam emissions. Now, La Palma on the Canary Islands, again, I was watching it for 30 days before its eruption. This was a 19-day period, September 1 to September 20, just before its eruption. So let's go on to the current time period. Now, Indonesia, this is an accumulation of heat detections following the 7.8 earthquake at the Banda Sea. This is an accumulation for approximately 7 days. So Mount Tambora, we have this spread of heat indications, obviously indicating magma moving into its magma chamber, heat within the crater, heat detections around the perimeter of Mount Tambora. This is not a fear-porn video suggesting Tambora is going to erupt in the near future. However, when we start having earthquakes at Mount Tambora in conjunction with our heat detections, then these should be noted. 2.9 yesterday, very shallow. Today, right next to Tambora, we had a deep 3.5 at 192 kilometers. So as we descend into the next grand solar minimum at the tail end drop of the current solar cycle 25, this is when we're going to have an uptick in volcanic eruptions and earthquakes. However, as we are now getting into the solar maximum, and will be a solar maximum for 2 to 3 years with our weakening magnetosphere, we can then have another uptick in volcanic eruptions and earthquakes. One moment, please. So this video is strictly on Mount Tambora, the history, and the fact that she is heating up again with some minor beginnings of seismic activity indicating movement of magma into Mount Tambora. And that's it for this video, folks. Thank you very much for watching.